Alright guys, we keep practicing with quadratic equations, and right now we are going to explore the null factor law or the null factor theorem. So let's consider what it's all about. It's about, remember before we practicing with simplest form of the quadratic equation, so x squared equals some k. So let's speculate if k is 0. What we have? We'll get x squared equals 0, and in this case we're pretty sure from the previous video, someone who didn't watch that, just go back and start watching that and also try to do revision to better understand what we're doing here. So in this case we have the following, so k is 0, x squared is 0 then, and we should have one solution. But technically it means that what if is x squared equals 0? That simply means that if we take x and multiply by itself, we'll get 0. So obviously, you have something multiplied by itself and the result is 0. When two factors multiply by each other and they are identical and the result is 0, we can have an outcome that each factor might be 0. In this case, they are the same, so we have basically two solutions that coincide, and that's why we have one solution. Alright, but we notice from here that each factor has the possibility to be 0. So that's why in a case when we have, let's say, quadratic equations which are not in this form, probably let's say in general form, x squared plus, let's say, bx, and even maybe plus c, we need to have an alternative approach, and this alternative approach is to, it comes from factorization or factorizing. So our goal is to split or factorize this quadratic expression into two linear factors and equate to 0. So from null factor theorem, if we know we have the product of two or more numbers or even expressions is 0, so right now we have expressions here, something from x, right? Something from x, and then at least one of them, means one of their factor is actually 0. So we equate each factor to 0. That's possibility from where we can complete two separate equations. So technically it means that if we have a times b, two factors, no matter what stays instead of a and b, there might be the whole expressions, let's say 3x plus 1, for example, times, it might be x, just single term x, and the result is 0, which is simply need to do the following. This is what is known a, and this what is known b. So technically we have a times b, and the result is 0. And then either a or b must be 0 in this case, or both probably. So that's why we have the chance to resolve two simplest equations which are mostly in the linear form. If we have quadratic equations and we are able to factorize them into linear one, we'll get two linear factors. Simply like 3x plus 1 and another factor is just x. In this case, we equate each factor to 0 according to this theorem, and we just solve normal equation like 3x plus 1 equals 0, and we have another factor, x is 0. So from where we can say that x1, the first solution here, is -1/3, and x2 is 0. Okay, hence we can find out solutions in the end. Okay, so let's try maybe to practice a bit more, and here I'll consider more complicated case, like we already have two factors, x minus, let's say, 3 and x plus 1. The result is 0. In this case, we have again two factors that might actually product of two or more. So we actually can have like 3 factors, 5 factors, but for quadratic equation less likely you might have that. at the most you'll have 2 factors here. Okay, so how to solve that? Again, you just simply notice that according to the structure, let's say the whole first bracket is A, the second bracket is just B, and the result is 0. Using the null factor theorem, we might have the following. So A equals 0, B equals 0, and we just set up 2 equations which we need to solve. Okay, how to solve? Just simply try to remember approach that are used for linear equations. So we get x equals 3 from the first one and x equals -1. So keep in mind that if you have 2 factors and each contains linear expressions, so you might have 2 solutions, and you should have 2 solutions in this case. And just remember, if it's quadratic equation, x squared plus bx plus c, it can be always represented as 2 factors. So there might be the case that 2 factors might be coinciding. However, that's not necessarily that each one must, so it's not necessarily that the whole result might be 0. But because we set up an equation, we should have like solutions anyway. Okay, so let's try to practice with already given examples here. So if you can try by your own, just pause the video and try to solve by your own. Here I'll try to explain. Okay, so the first one, x times x minus 5. We have 2 factors, the first and the second, and each factor might be 0. So that's the first solution, and the second solution, x2 equals 5. So the next one, 3x times 7 minus x equals 0. Let's practice. So one factor is 3x, but we have actually 3 factors, and 3 never can be 0, so because it's a positive number. So we have only x equals 0 and 7 minus x equals 0. From where? That's the first solution, and the second solution is 7. All right, let's move next. We have 3 factors, but if you have the number, and number is always definitely it's more than 0, so it can never be 0. You just get rid of 11. So if you want, you can even divide by 11, but this is sort of redundant operation. Just forget about that, you have a number here. Okay, so now you have x plus 2 and x minus 7. So we equate each factor to 0, and we'll get x plus 2 is 0, x minus 7 is also 0, from where we can figure out the first solution and the second one. All right, here. How many factors you have here? What do you think? So many students like trying to answer, we have 2 factors, 4, and what do you have here? So actually, they are correct somehow, but if you consider 5 minus x as 2 brackets multiplied by itself, so simply 2 identical brackets, you'll get 3 factors in total. You can consider this as the only factor with the 4, so you have 2 factors in this case, but inside actually there are 2 factors in this expression, so it's more correct to use 3 factors in a row, and simply each factor might be 0, because otherwise you need to solve like something 5 minus x squared equals 0, from where you need to take square root of k, because this is the simplest form. However, it's better to represent in this way. It will really help you when you solve inequalities. So always try to consider as this one. Okay, so 5 minus x, 5 minus x, both 0, so we have x1 and 2 just coincide in solution, which is 5, right? Okay, let's move next. Here we have again 3 factors. 4 is never 0, so we equate 2 other factors to 0, and we'll get the first solution -6, and from the second one we have x2 equals 3 over 2. Here we have -6, which is never can be 0, and x minus 5, the first possibility, and the second possibility. So we'll get x1 solution equals 5, and x2 equals negative 2 over 3. That's it, actually, that's it. However, I promise you to provide the case when I was talking about that this expression might never be equal to 0. Okay, let's try to have this case. For example, you have x squared plus 1 equals 0. Is it possible to factorize this expression? Let's think. X squared is just one term and there is no common factor with 1. So what to do next? Alright, you need to analyze this expression, x squared plus 1. Is it the chance that this expression might take the 0 value in total? So we consider this as the whole expression. Is it any x delivers you 0 in as the total value of that expression? I think no, because let's figure out in two ways. First, let's do it graphically. It's a little bit forward, but you need to be able to know these details because someone just revising and probably he or she already knows something about functions and graphs. So let's say x squared plus 1, this is the function. It's parabola, right? Because it's quadratic function. All right, let's try to do the following. We'll try to say that using transformation theory, we can state that there was x squared, the graph of the parabola, and it's sort of like a smile with the vertex in 0, 0. And now it moved 1 unit up. So right now, the actual graph, I put a red color for that. The actual graph is here, so with the vertex lifted by 1 unit up. The shape is not changing. So right now we have the graph that completely above your x-axis. So that's why for y value, y is always positive. So in this case, we have left-hand side, x squared plus 1, which is the function, is always positive. So it can never be 0. So in this case, x, no any value for x that delivers you function to be 0. So in other words, you don't have 0 as a function. So that's why x just no solutions or just empty set. You can say that x is an empty set, so no solutions. Okay, let's analyze algebraically. So algebraic approach. We don't use any graphs in this case, and we just simply need to say x squared plus 1, how we can estimate the value for x that delivers you the total expression to be 0. So we analyze x squared, the minimum value is 0. So because totally x squared is the value that's more equal than 0. Let's say indeed, take 1. 1 squared is positive. 0 squared is 0. Negative 1 squared is also positive. So it can never be negative. And on top of that, you add 1. So the whole expression completely positive. So that's why it can never be equal to 0. So x squared plus 1 never equals to 0. So no solution. So empty set. Okay. So we discussed that sometimes you might have no solution, and means, in other words, it's not possible to factorize. However, about factorizing, we'll just consider that in the next video. So hope you enjoy, guys. I hope you understand the core idea of the null factor theorem or null factor law, and there we will apply that in order to solve quadratic equations. So in the next video, we just consider steps necessary to solve quadratic equations in standard form, like x squared plus bx plus c. So one more time, hope you enjoy. Don't forget to subscribe and share these ideas to anyone interested in maths. Okay, and see you later.